Welcome everyone! Today we're going to crack open your machine learning assignment for SWE 624. Think of this as your personal playbook. We're going to transform that assignment brief from a wall of text into a clear step-by-step guide for success. Okay, let's get right into it. First things first, you need to appreciate the weight of this thing. This single portfolio, well, it's worth 100% of your module grade. That's the whole shebang. So having a solid strategy isn't just a nice to have, it's absolutely crucial. So here's how we're going to tackle this. First, we'll define the overall mission. Then we'll dive into task 1, the theory part. After that, it's on to task 2, the big practical project. Next, and this is super important, we'll decode the marking rubric so you know what they're looking for, and we'll wrap up with the essential rules you gotta follow. Right, so let's zoom out and look at the big picture. For this assignment, I want you to stop thinking like a student and start thinking like a junior machine learning consultant. Your job, your mission, is to deliver a professional grade portfolio that really shows off what you know and what you can do. So your mission is split into two parts. You've got the practical project, which is the bigger slice of the pie at 60%, but, and this is a big but, do not sleep on that 40% for theory. It's designed to prove you've got the foundational knowledge down. You really need to nail both to hit those top marks. Okay, let's get into the first part of your portfolio, what I'm calling the theory gauntlet. This is where you prove you have a rock-solid grasp of the core ML concepts. It's 40 marks, so let's see what's involved. First up, you're going to get 4 different scenarios. For each one, you have to identify the right type of machine learning. Is it supervised, unsupervised, reinforcement? But here's the key. You can't just name it. You have to explain exactly why it's the right choice. The reasoning is everything. So if you see a scenario about forecasting weather, your brain should immediately start thinking, what kind of data do we have? We've got historical data with clear outcomes, right? It's labeled. That points straight towards supervised learning. That's the kind of thinking process you need to show. Now you're going to hit a really important 8-mark question. What is the difference between k-means and k-nearest neighbors? They sound similar, but they're worlds apart. K-means is unsupervised. It's like being given a box of random Lego bricks and asked to sort them into piles by color and shape. You're finding the groups. KNN, on the other hand, is supervised. It's like having those sorted piles already, and when you get a new Lego brick, you decide which pile it belongs to by looking at its closest neighbors. Getting that distinction right is crucial. The theory section doesn't stop there. You'll also need to get your head around some other core ideas. You've got to define what loss is, basically how a model knows it's getting something wrong. You need to explain overfitting, that tricky situation where a model knows the training data too well. And really importantly, you'll need to analyze the real-world challenges of AI, things like bias. They want to see you've thought deeply about this stuff. All right, let's move on to the main event, the practical project. This is where you get your hands dirty, where you apply all that theory, and it's worth a whopping 60 marks. Now, the great news is that this huge task is broken down into 4 pretty logical steps. You'll start with just exploring and cleaning up the data. Then you'll select and test out your model. After that, you'll work on fine-tuning it to make it better. And finally, you'll wrap it all up with your conclusions in a professional presentation. So what's the actual job here? In a nutshell, you're building a regression model. All that means is your goal is to predict a number, a continuous value, which in this case is the selling price of a house. You'll use all the features in the dataset, like square footage or the number of bathrooms, to make that prediction. And here's a key point. It's not enough to just build a model and say, hey, it's done. You have to prove it's any good. That means you've got to choose at least one regression algorithm, train it properly, and then evaluate it using the right tools for the job, metrics like mean squared error and R-squared. Okay, this section is maybe the most important one. This is how you take your work from being just good to being great. To really aim high, you have to understand exactly how you're being marked. So let's decode that rubric. So this is the big question, right? What's the real difference between getting a solid B and getting an A? Well, it's not about writing more pages or adding more code. It's all about the depth and quality of your thinking, and the clues are all laid out for you in the assessment criteria. To push into that top band, you need to live and breathe these keywords from the rubric: exceptional, professional, and nuanced. So what does that actually mean? Well, nuanced means you don't just define overfitting, you explain how you saw it and dealt with it in your project. Professional code isn't just code that runs, it's clean, well-commented code that another developer could understand. It's this next level quality that the markers are looking for. And this quote, which is pulled straight from the top grade criteria, says it all. The goal isn't just to tick the boxes, it's to produce a report that shows you've gone beyond the basics, that you've brought some original thought and creativity to solving the problem. That's what really stands out. And finally, let's quickly run through the rules for success. This is your final checklist. Getting this stuff right is an easy way to make sure your hard work is presented properly and you don't lose marks on simple technicalities. So pay really close attention here. Keep your eye on that 3,000 word count. Make sure your referencing is perfect Harvard style with at least 5 to 10 sources. And please, don't forget professional touches like a table of contents and page numbers. These are simple things, but they show you're taking it seriously. Okay, I need everyone to listen up for this one, because it is a critical rule. The module guide is extremely clear. You cannot use any generative AI tools for this assessment. If you submit any content created by a GAI as your own, it will be treated as academic misconduct. This entire portfolio must be your own work, period. So there you have it. That's the consultant's playbook. You have the mission, you have the step-by-step breakdown, and you know what true success looks like. The rest? Well, the rest is up to you. Time to get building. Good luck.